All right, so I'm working on working on the motor controller for the trike, and this is the one I got. I got a 24 volt one, but it's really small. It's like 250 watts, and I tried it and it didn't actually work. So I pulled out this one, which I already had, but it's a 36 volt, so it. Which is, you know, it has twice as many FETs as the other one, because, well, it's a 500 watt versus a 250 watt. So you'd expect that, but the key is that it works at 36 volts, and I want it to operate at 24 volts. And if you take these apart, you can see that there is a resistor divider that takes the voltage input and divides it down to 5 volts, and it's these resistors right there. And if you look at the board, you can see they have markings for 60 volts, 64, 72, and 90. So you can jumper these pads and get it to have that voltage cut off. Because really all what this is doing is determining at what voltage does the controller turn off. I'm getting a lot of glare. Turn off. But notice there's not one for 24 volts. And so what I need to do is remove that resistor and replace it with one that is the right resistance. So I'm going to have to do some calculations on that. I'm going to first of all confirm that that's the resistor I need to change. I pretty much believe it's a ratio. You can Google, you know, voltage divider and get more information. But basically, there are two resistors, this one and this one. So the power comes in here. It goes through. This goes to ground. And then the output looks like it goes right here and then ends up going to the computer, this CPU right there. So if you select, you know, these other ones, it changes which resistor is the first resistor in the divider. So I can't use those, but I'm going to use this. So I'm going to have to remove this resistor and put a different one in. Now I've done this twice already on this controller, because I've built other bikes, and that's why I use the same one. I get the same one because I know how to do it. However, I didn't write down what resistor I used, and you know, now I have to figure it out from scratch again. So basically, what I do is I'll just measure the resistance of those two, and then calculate which one will give me 5 volts. And I'm pretty sure it's 5 volts, but I have to confirm that. So I'm going to power this. I'm going to power it up with 36 volts, and then see what voltage comes out. And where's my little stick? See what voltage comes out right here with this spot right there. And then I'm just going to calculate the resistor that produces the same voltage for 24 volts. So let me show you what we got going here. I got a 12 volt power supply right there, and that is feeding in to this DC to DC boost converter, so I can generate whatever voltage I want. I just adjust this trim, and you can see this is the output voltage. I got it at 31 volts because that is the cutoff voltage for a 36 volt controller. So, you know, I just have it connected up to the power, and I also have to connect it to the turn on wire, which I forgot initially. So so now we can go to the resistors, and you can check the input to the top of the thing is now 31 volts. If you go to the other side of that resistor, it's 2.38 volts. So that's what we need to generate at basically at 20 volts. I think it's 22. And because I'm using lithium iron phosphate, they have a lower voltage than lithium ion. So I'm pretty sure it's 2.5 volts is the cutoff, is dead on a lithium iron phosphate. So do the math, 2.5 times 8 is 20. So I gotta set this cutoff at 20 volts. So when it's at 20 volts, I need this to be at 2.38. Okay, I got the tripod set up. Look at me, I'm being all fancy. Show you what I'm doing. So basically I got the multimeter and I've got it set on resistance, ohms, and then I take the probe and I can measure the one that goes from the center to the ground, and you can see that's 2K. So that's 2K. I should write that down because I will forget it. 2K. And then I'm going to measure this one, the one that goes from the center to the input voltage. And that's showing 24K. See that? 2395. So that's 24K. All right, so we have a, let me get a piece of paper. So we have a resistor divider. So there's a resistor here, and a resistor here, and this goes to ground, and this is our voltage, our input voltage. And right here at this point in between, this needs to be 2.38 volts. And so we've got, this is right now 24K, and this is 2K. So if you go on the internet and do voltage divider calculator, let's see if I'm on the internet right now. Here to work. So if you go to the voltage divider calculator, which is, it shows you right there. Hopefully you can see that clearly. You've got two resistors. You've got the first resistor, the second resistor, and then the center point. And that's, if we plug in the numbers, we got 31 volts as our source. We got 24 K ohms as the first resistor, and we've got 2 K ohms as the second resistor, and then the middle point, look at that, it comes out at 2.38. Imagine that. That's exactly right. So now we need to change this to be 20 volts, and we want to make sure we get this back the same as 2.38. So we're going to need to change this. So we just erase it and do calculate. It will tell us what it needs to be. So it's 14.77, and I probably don't have a 14.77 resistor. Collection of them, an assortment, and we've got 15K. So if you look right there, you can see that. There we go. So 15K is one that I should be able to have if I can find it in the collection there. So I'll change this to 15K, and then see what my voltage gets to be. 2.35. That's pretty good. But let's change this to 2.38, and then erase this and see what 20.23. So it raises the voltage a little bit more than 20 volts. Then it'll be cut off at 15K, and that's perfectly fine. So, all right, I am gonna find the 15K resistor. It's got this it's got this paste, and I just can never remember not to touch it, because you want to just touch that edge. So we're just going to take the soldering iron. I had to change tips to a finer tip and just heat up one side and kind of lift it up. I just give it a little solder on a little bit, like yeah, I moved it off. All right, so that's gone. That's off of there. So now I got to put the new one in, and the new one in is smaller by quite a bit. I need some tweezers for this job. All I got to do is get each end . Soldered on that, and I put some more in there just for good measure. All right. So now we have to check it, and you know, get my ladies' glasses back on. See where we're at here. Okay, 19.5. That's 19.5. How can that be? Now, you know, I might have just blown up this chip, because now it's feeding at 19.5 volts into one of the pins. And you know what? That might have just blown it up. Oh. No. No, because I don't have the ground hooked up. That's what it is. I don't have the ground to the... Or I don't have it turned on either. Yeah. There we go. So yeah, I didn't have the ground hooked up to the power input. So... yeah, because we had 19 volts, which wasn't really right. So 20.3, and our output is 2.38. Alright, so it's fixed. So now I can disconnect everything. Start with disconnecting this. Alright, so all I need to do is just put this all back together inside the case. Okay, I got it hooked up. Now I can show you it working at 24 volts. So I took out the third battery, which would make it 36. So I just have 12 and 12 is 24. Connected in series, plugged into the controller, and you gotta, don't forget to hook up the power wire, the on switch. And then we've got this is the throttle controller. And of course it plugs into the motor. And I got it. Oh, gotta jack up my jack so the wheel's off the ground. So then we got the throttle right here. Just you can hear it going, and it's not going to go fast. So you know, We don't want to go fast. This thing is going to go slow and steady, because we don't want this trailer to be going fast. So there you go. It works. Okay, let's put my face in there. All right, don't forget to subscribe and like and share and join the Patreon, because I'm giving this thing away. All right, thank you for watching. See you next time.